My name is Ilkka Leinonen. Today we are going to discuss about the OWASP Top 10 API security threats for Friends platform. So, where does corporate business data be secured? We all know that the corporate-wide operations are broadly supported by IT systems. Different kind of integrations rely strongly on data exchange. Different kind of data exchange and transfer across departments and stakeholders happens on daily basis. While the data exchange process is running between corporate-wide functions, external partners for business to business and consumer services are always in a risk that the sensitive data may get jeopardized. Luckily, there are several different kind of mechanisms how to prevent different kind of security attack towards the system or your open APIs. The most commonly known vulnerabilities are the OWASP Top 10 attack vectors. So what are the OWASP Top 10 security risks? On the left side, you can see the actual list. So we have the broken object level authorization, broken user authentication, excessive data exposure, lack of resources and rate limiting, broken function level authorization, mass assignment, security misconfiguration, injection, improper assets management, and insufficient logging and monitoring. In general, we are going to discuss about the Friends security threat diagnostics, how we prevent different kind of attacks towards the system. First of all, we are going to look a little bit about the theory behind the platform. So 40% of the internet breaks happens behind a firewall. That actually means that your own local area network can be jeopardized with different kind of stakeholders who are not the most secure persons on your corporate. Different kind of breaking mechanisms, hacking attempts can happen also on the northbound interfaces. So both needs to be secured, the northbound and southbound interfaces. And what we need to do, we need to have a diagnosis in real time near to the actual data sources. Those data sources may be Excel files, databases, REST services, product services, ERP, CRM, etc. But we need to have a governance over the data, which will be exchanged between different kind of IT systems. The overall business detections rose 79% from 2017. What we can provide from the security threat diagnostics point of view, we will have security rule validations against common vulnerabilities like injections, SQL injections, XSS attacks, etc. We are also providing web application firewall level IP address white on blacklisting, and also allowed HTTP header validation. So data flows across databases. We have different kind of ways how to transmit information or exchange information between different kind of IT systems. We have Excels, BDS, flat files, and more, which are exposed for data manipulation and hacking of the content. There's also a lot of different kind of sensitive data, such as personal information and customer registers, containing information which should not be exposed to public APIs. Both the northbound traffic, meaning internet, P2P and P2C, and internal southbound interface traffic, meaning the local business area services on daily operations, expose threat for business critical data. So here you can see a drawing where we have the different kind of hackers involved. So first of all, we are able to pull information from file system. We are able to read CSV files, which could have some sensitive data which are manipulated. If we don't have any proper mechanisms how to prevent different kind of hacking attempts, that poisoned information will be inserted into a database. And then that might cause the actual database or middleware or some other layer of the system to be jeopardized for open data. So data exchange can contaminate the business data in various IT systems. This actually means that the data is exposed for hacking by in-house employees or consultants like IT developers, database administrators, testers and other personnel, or then a social hacking by intruders. So when the data flows across several business services, the hacked data, meanwhile, may contaminate various IT systems such as middleware, databases, operating system, among other software services. So 40% of the internet breaks happens behind a firewall. So the data exchange happens regularly on daily operations in organizations. And it can happen using different kind of modern interfaces like REST and JSON, web services, microservices, SOA. In addition to those, the data could be manipulated by different kind of documents like Excel sheets, PDFs, Words, keynotes, flat files, or even the actual product services running on software as a service, cloud environments, ERP, CRM, HR tools, and others. So the trend shows that the digitalization and modernization of legacy systems are moving towards open data-driven business and Internet of Things. That actually means that the business critical data gets exposed and published for different kind of mobile devices for P2P and P2C channels. When publishing the data into a public internet or demilitarized zone, it might cause the underlying master data system to be challenged for data manipulation attempts due to an open data accessibility. On the lower picture, you can see a presentation how different systems can expose information. On the bottom side, you can have different kind of ground systems, on-premise systems. They might be also public cloud infrastructures. Then on the integration runtime, you can have the connectability to different kind of system API layers. System APIs may be microservices, SOA, they might be databases, Excel sheets, whichever makes the business to work. On top of the integration runtime, we have the API management, where we have the capability of having the different kind of version control system, managing of the API lifecycles, and the API analytics. On the actual API gateway side, we have the capability of load balancing and routing into different kind of environments like ground environment and cloud environments, wherever the actual execution environment exists. So what we're able to do with the API gateway, we're able to secure the APIs using API policies, expose the API developer portal, and publishing API into a cloud or ground environment. So let's see what kind of prevention mechanisms do we have for the OWASP top 10 list. So first of all, the broken object level authorization. French provides a role-based authorization with both OAuth 2.0 based services and API keys based services. And platform provides tool for claiming specific scopes for defined operations. It is possible to claim the specific CRUD operations. CRUD actually means to create, read, and update and delete different kind of object level data. During the PPMN 2.0 process execution, the token from the authentication chain, the platform verifies the content of the known claims and compares the actual result for process execution. And you can actually create claims or rules for both allowing and denying the object usage. So in the example left, you can see that we have defined a token issuer, who is the trusted partner. Then we have a claim where we actually read, we have a read operation for products. So we allow reading of the products. The next one, the broken object level authorization. So French provides technical API keys for accessing both the northbound and southbound services, That actually means that you can publish interfaces for internet and also for your local area services. Service clients whom are using the actual interfaces needs to have the HTTP header API key available through the request, so they are able to successfully call the services. You can actually have several different kind of API keys, for example, for development, testing, and production services. And you can apply rule sets for authorization, the API operations, in addition to threshold levels. You can attach several technical users or accounts into the same API key. The third one is the excessive data exposure. So French provides an open API-based service tasks for semantically coherent interfaces for both successful operations and declined operations. So you can actually limit and filter the whitelisted IP address blocks and also have a deny or blacklist specific IP address blocks. That actually means that you can run the integration runtime on your own ground environment or on-premise isolated network. And you can specify the client connections directly for specific IP addresses. You can also define a block of IP addresses. Each invalid IP address makes a system to throw an exception, which makes the caching of an exception as an imperative action. What does it actually mean? That when there's an IP address, which is not part of the whitelisted or blacklisted IP addresses, the system gets notified. And then you have another queue for processing these kind of queries. These messages are called, the invalid IP address messages are called the dead letter channel, where you can push the information which is coming from unknown IP address. This channel might be a sub-process which manages the faulty messages asynchronously by the administrators for sanitation of the messages. The fourth one is the lack of resources and rate limiting. For denial of service-based attacks, French provides the threshold levels for limiting the transaction amounts. Distributed denial of attacks might be coming through both from northbound and southbound interfaces. So it actually means that they could come, the attacks could come from trusted partners or then a widely open network, in addition to local area services. There might be a worm inside of your network which causes the denial of service attacks from in-house API towards the in-house APIs. And that actually jeopardizes the corporate essential business services. You can actually specify the threshold limitation using the time interval for seconds, minutes, hours, and weekly basis. The fifth one, the broken function level authorization. French provides a role-based rule set for accessing open API or Spacker-based services. You're able to choose from underlying HTTP REST protocol operations, the standard operations like post, put, get, delete, options, the head and patch. These are actually meant for creating, reading, updating, and deleting. The API keys can be bound to specific technical users, and you're able to define the URL-specific rules. So actually, when you have different kind of rules for creating, reading, and updating or deleting, you're able to specify which rule or API key applies for a specific operation. The sixth one, the mass assignment. The French provides deep diagnostics to intercept and work as a web application firewall. So we prevent faulty headers. Only known headers are bypassed. And this happens on a TCP IP level. Actually, it's in a HTTP protocol with the HTTP headers. So you're able to whitelist different kind of headers like origin, connection, accept, etc. We provide over 79 validation rules against commonly known attack vectors for payload attributes. and working as an intrusion detection backend. So actually it means that these HTTP headers may be contaminated by different kind of scripting, and we have a validation rules against them. We are able to calculate hash keys with predefined salt to calculate the attributes on a request if needed. Also, double encoding verifications for URL manipulation attempts can be applied. You're able to define the whitelisted TCP IP headers for making entry into the system, such as origin, connection, or accept, in addition to URL and possible redirection URL to be used with HTTP protocol headers. The seventh one is security misconfiguration. So what we have is, friends, we have the controlled configuration and centralized configuration for different kind of environments. So you can actually configure different kind of groups, which actually means the configuration parameters for different kind of environments to be used in a process execution lists, a static list of parameters bypassed to be used in the process execution. Also text-based configurations and secrets, which are stored in the key vault, numbers or numerical configurations, and also Boolean values. So what you can actually do, that you can have several different kind of environments like development, testing, and production. And for each environment, you can define the specific set of variables. And you can have the security over different kind of passwords or technical usernames, which are stored into a key vault. Number 8, the injection. So Friends provides over 79 injection prevention mechanisms. So we have a deep diagnostics, how to prevent different kind of attacks like SQL injections, XSS attacks, HTML break injections, whitespace attacks, JSON referrer attacks, XML predicate attacks, SQL bypass attempts, function declarations, XSS denial of service attempts, command executions on the OS level, and much more. These rules can be challenged against any data flowing from northbound and southbound interfaces. In addition to validation of the data payload and its attributes, you're able to manage and sanitize the faulty messages with invalid message channels. So when you can see on the left side picture that when there is a found security threat on the attribute of the actual content which is flowing through the system, you can raise an exception. And while you raise the exception, we can catch the information what was sent into the system, and we can utilize asynchronous invalid message channel processor to push the data into an administrative action queue. Number 9. The Friends control panel provides user interface for staging environments such as dev, test, and production. Each environment has specific capabilities for publishing services and links using port openings. It is important to make routes through the corporate security routes inside the trusted backbone services. Platform can be configured to publish through API gateway parameterization related to the usernames, passwords, DNS, ports, external address, and SSL certificate thumbprints. So this is the actual environment-specific configuration. And you can utilize the staging of the platform, the staging capabilities of the platform for supporting your DevOps actions. Number 10, the insufficient logging and monitoring. So the event flow of the process execution can be viewed as step-by-step and used for debugging and monitoring. Data quality of the process instances can be verified. You're able to zoom into the peak hours of the trend data and filter by search and logging level. French provides centralized monitoring window, which provides filtering and zooming options for transactions. All of the events will be logged into the system and provides audit trail for business critical operations. You're able to define the logging level, and you are able to filter the instances. You're able to zoom into the actual monitoring view, and you can have the real-time values, what is happening during the process execution. On this slide, you can actually see the different kind of prevention mechanisms which are happening inside of the platform. And now it is time for a demo. So let's jump into one specific demo. So on the left side, we have a trigger which initiates the actual business process. If you open that one up, we can actually see that it's an open API-based service. This service could be utilized by mobile devices, or it could be utilized by back office tools, a web page, a portal, which could send customer information into the backend side. What we are building here, that we provide two different kind of API keys for two different kind of customers. We have a create interface, and we have a payload attributes. We have the name, address, and mobile. And we get a response back, a transaction ID. So what we are going to do, in the first step, we are going to diagnose against the security threats. In the first attempt, we are going to look how different kind of name, address, and mobile, what is the content for them? Are they having some kind of a security threat, like SQL injection, XSS attacks, or other scripting? We also make the information check for all of the relevant parts, the sum of the all of the possible attack vectors. We also do the challenging of the IP addresses. Whitelisted IP addresses are here available, where you can actually define the source IP address block. You can also add several different items from different several networks. And you have also the blacklisted IP addresses. So you have the capability for both. We also take care of the security headers, which happens on the TCP IP level. So we have the origin, connection, accept, and so on. Different kind of headers to be verified. And finally, we have the challenging of the character encoding. Which kind of encoding is it coming from? Is it UTF-8, ISO 8591, or some other? And we make the character encoding verification. When we have looked all of the relevant injection attempts, we are able to look, was the messaging secure? If it was secure, we create a transaction ID. We add the transaction ID in the secure message. Then we utilize event-driven architecture. We use RabbitMQ to store the information in the backend side. And finally, when we have stored the information in the backend side, we will return back the transaction ID, which was created here. The actual business rule validation happens on the microservices, which we are calling through the RabbitMQ. If we have some fault information, invalid messages flowing in the system, we will gather more information on the backend side and then send that information into administrator. And after that, administrators are able to read the information from different specific messaging channels. It might be invalid message channel, dead letter channel, or others, which are there for as a sub-process, reusable sub-process for faulty messages. So let's see. So let's start a demo. So let's first copy the API key so we're able to access the services. And let's open up a Swagger UI. Let's authorize the call with the API key. And let's try it out. Here we go. So now it's sent into the backend side. As you can see, we have the response, server response to 100, which makes the backend work as expected. And also the response body, we got the transaction ID back. We have some security headers also involved. Content security policy, content transfer encoding, and so forth. We can also verify that we can do the same on the backend side. And now we can see that we had two different messages. Here you can see that the success factor were the correct ones. So we defined the name, the address, and the mobile. And from the process execution point of view, everything went correctly. And we had the transaction ID from the backend side. So let's go back. And write a script. So let's make a simple but effective XSS attack. Let's call alert function. And let's call the function itself. So we build a script and we call the backend side. And we can actually see that there was 419. So there was some kind of a faulty messages. So let's go back and review what happened. And here we can actually see that we got the information. The payload contained the script, the attack function. Any script kiddie could do this. So we go back here and challenge the attributes which were coming from the payload. So let's see. So we tried with a script XSS attack, and you can actually see here that we have validation patterns. These validation patterns exist. We have over 79 validation patterns for preventing false messages into the system. So these false messages might be coming from different kind of end user interfaces, like mobile devices with form submission, or they might be coming directly from different kind of Excel sheets, PDFs, documents, Words, or databases, REST services, web services, whichever exists. If there's a contaminated content, we will look into that part and verify the functionality. Because we found an attack, we raised an exception. Now we are going to catch that information and push that information by using a RabbitMQ. So we send that information into the backend side for further processing. The IP addresses were correct, the security headers were correct, and the character encoding was correct. But we failed on the attribute level. And we can see that we need to gather more information about the attacker, and we will send this information for the backend side, for administrative actions and possible criminal investigations. So what you can see here is to have the environment variables, which are centralized. You can specify different usernames, password, addresses, which are essential part for different kind of environments. You have development, testing, production, container services, and we can have centralized configuration over the items. We can manage the environments quite easily. We have a simple user interface for adding more environments. For each environment, we have the capability of configuring the different kind of environments. And also, we are able to see the logging level inside the system. Whatever happens inside the system log, we are able to see that. In addition to that, we are able to build new API keys and define a request limit. And also we are able to allow different kind of rule sets. So different kind of rule sets contains the operations for persisting the information. You can have different kind of methods like get, put, post, delete options, head and patch for different kind of URL configurations. And you're able to define several different rules for one API key. And also you can define on an access level these different kind of scopes. So if you have products flowing through the system, you're able to define the read rule and then define the scope for that. Good. So I think we are good to go. Yes, so you'll feel free to contact me related to the security of your platform and issues on your daily operations. So let's review them, and we actually have and we are going to have more this kind of a business from business perspective, this kind of rule validation book or templates also from as a manual reading, not only for the platform, but also that you can actually see what are the essential parts of having the security on board. So please let me know if you're interested or want to hear more about the state of the security.